In this video, we study a special type of sequence known as a recursive sequence. A recursive sequence is a sequence in which one or more of the first few terms is given, and all of the other terms of the sequence are then defined using the previous terms. For example, this problem says, write the first four terms of the sequence defined recursively. We are given the first term of the sequence. A1 is equal to 25, and the equation that defines the remaining terms of the sequence is a sub k plus 1 is equal to a sub k minus 5. Notice it looks a little bit different from all of the other sequences that we have looked at so far. Well, if we need to find the first four terms, the good news is that we already have the first term. The first term of the sequence is 25. That is a sub 1, a subscript 1. The next term in the sequence would be a subscript 2. Notice that the subscript here is a 2. Well, let's look at this equation that defines each of the terms in our sequence. A subscript 2. The question we have to ask ourselves is, what number would we have to plug in for k to get a subscript of 2? What would we have to plug in for k to get a subscript of 2? Well, the answer to that question is 1. If we plug in 1 for k in this equation, we get a subscript 2. And if I plug in 1 for this k, that means I have to plug in 1 for every other k that I see. I plug in a 1 for k here. That gives me a sub 2 is equal to a sub 1 minus 5. A sub 2 is equal to a1 minus 5. Well, a1, that's the first term in the sequence. That's equal to 25. So we can replace that, giving us 25 minus 5, and 25 minus 5 is equal to 20. The next term after a2 would be a subscript 3. Again, here is the equation that defines each of the terms in our sequence. If we want the subscript to be 3, we have to ask ourselves, what would we have to plug in for k to get a subscript of 3? Well, to get a subscript of 3 here, we would have to plug in 2 for k. Notice that plugging in 2 for k, 2 plus 1, that would give me a sub 3. And because I plug in 2 for k here, that means I have to substitute in a 2 for k everywhere else. If I plug in 2 for k, I get a sub 3 is equal to a sub 2 minus 5. A sub 3 is equal to a sub 2 minus 5. Well, a sub 2, that's what we found previously. That was the previous term, 20. This is 20 minus 5, which is equal to 15. And the next term would be a subscript 4. Again, the subscript here is 4. We need to ask ourselves, what would we plug in for k to get a subscript of 4? Back here up in this equation. Well, to get a subscript of 4, we would have to plug in 3 for k. If I plug in 3 for this k, I have to plug in 3 for this k. That tells me a sub 4 is equal to a sub 3 minus 5. A sub 4 equals a sub 3 minus 5. A3 is the previous term, 15. 15 minus 5 gives us 10. Let's try one more. Write the first 5 terms of the sequence defined recursively. And in this case, notice we have a0 equals 1 and a1 is equal to 0. Okay, so the first 2 terms in this case are actually given. The first term is a subscript 0, and the second term is a subscript 1. We are given the first 2 terms of the sequence, and the remaining terms of the sequence are going to be given by this equation here. A sub k is equal to a sub k minus 2 plus a sub k minus 1. Well, as we've already said, the first 2 terms of the sequence are given. A0 is equal to 1. A1 is equal to 1. Don't be afraid if the first term is 0. They will tell you that, as you see here in this particular problem. Well, the next term, if we're going in order by integers, 0, 1, the next term would be a subscript 2. Notice that the subscript is 2. So we come up to this equation here. and we ask ourselves, what would we have to plug in for k to get a subscript of 2? Well, in this case, to get a subscript of 2, we have to plug in 2 for k. And if I plug in 2 for this k, that means I need to plug in 2 everywhere else I see a k. If I plug in 2 for k, I get a sub 2 is equal to a sub 0 plus a sub 1. A2 equals A0 plus A1. A0, that's given as 1. A1, that's given also as 1. 1 plus 1 leaves us with 2. That is the third term of the sequence. The next term would be A subscript 3. Well, we come up to our equation that defines the sequence. We need to make this subscript 3. That means, what would we have to plug in for k to get a subscript of 3? Well, we'd have to plug in a 3 for k. And if we plug in 3 for k here, that means we plug in a 3 for k in each position, wherever we see a k. That would give me a subscript 3 is equal to a subscript 1 plus a subscript 2. A3 equals A1 plus A2. Well, A1 is equal to 1. A2 is the term that we found previously, 2. 1 plus 2 gives us 3. So we've got 4 terms now. To get the fifth term of the sequence, well, that would be the next integer up from 3. We would have A subscript 4. What would we have to plug in for k to get a subscript of 4? In this case, we would plug in 4. If I plug in 4 for this k, I plug in 4 for every k that I see. A sub 4 is equal to a sub 2 plus a sub 3. A4 equals A2 plus A3. A2 we found as being 2. A3 we found as being 3. 2 plus 3 gives us 5 for the fifth term of our sequence defined recursively.